everyone. This is a topic we are all thinking about, reading about, and really looking forward to talking to each other about. We are delighted to continue our work with Bill Bonvillian, an esteemed and thoughtful, multifaceted colleague whose work has included working in the US government. He was 17 years as senior policy advisor in the US Senate, an expert on technology and science policy, and then joined MIT and became director of our DC office that put him directly into conversation at the interface between MIT, the US government, and broader society in trying to understand big ideas, orchestrate new threads and themes in the work we're doing within universities across the country, and really putting the role of MIT as a science and tech leader in front of lots of different folks. Bill's been thinking a lot about AI and has invited our special guest for today, Professor Justin Reich. So I'll say a couple words about introducing him and then turn it over to Bill, who's put together some thoughts that could guide our conversation. Justin's an expert in learning, in digital media, in education. He's published all over the place: Science, PNAS, Washington Post, The Atlantic, and books, one of which you see right behind you. The book both his books tackle the kind of challenge of harnessing new, potentially really good ideas and turning them into practical, impactful ideas that work to improve education. He is director of the Teaching Systems Lab in the Comparative Media Studies and Writing Department at MIT. So he runs the show on research that looks at systematic, data-driven, and impactful ways to improve teaching. He's sometimes he hosts a podcast. Maybe we can get him excited to do a new J-Well inspired season sometime, and has been a fellow in various roles at Harvard, giving him a chance to really dig into big issues and policy issues. So now, Bill, help us think about the big questions on the docket today.
Thanks, Anjali. As all of us know, in November of 2022, OpenAI introduced ChatGPT to the world, and a lot of us have been communicating with ChatGPT since then, using it for all kinds of things, good and bad. And today's topic really is all about AI in education, and obviously it's a development that schools need to pay a lot of attention to, understand and grasp and figure out how to work with. There are a lot of potential uses of AI in education. The personalization of education, the ability to really produce materials that can be adapted to each student's individual learning needs, and really target instruction. And that potentially could lead to a system of digital tutoring. Always kind of a dream out there, but AI could help get us there. It can offer feedback for teachers on how their students are doing and help them target improvements by providing materials and approaches to students that need to catch on better. And it can also provide, meaningful and very quick, almost immediate contact feedback to students to help them avoid making the mistakes they could be stumbling into and get back on track. And it can also, and this is a potentially big use, reduce time on the burden of administrative tasks that all of us as teachers face. But there are obviously a series of potential drawbacks. One of those is reduced human interaction, a reduction of kind of face-to-face communication that can really negatively affect the development of social skills. And in turn, that's part of an overdependence on technology problem where students reduce their ability or motivation to kind of think critically and independently. They rely too much on AI as problem solver. Reduced interaction with teachers, AI as a substitute, yet teachers play such a critical role in fostering kind of emotional intelligence, critical thinking in students, this whole mentoring role that teachers are so crucial to, that we still very much need, of course. There's all kinds of data privacy and security issues, and there's deep ethical issues. AI can enable large-scale cheating. And it's hard to hold AI systems accountable for the information that they provide. So with all technologies, there are always a double-edged sword. There are great positives and there are potential negatives, and AI has got a lot of both. And here to lead us through this is Justin Reich, who's done a tremendous amount of thinking and work with AI, and can lead us through both the positives and the negatives. Justin, all yours.
Terrific. Thanks, Bill. Nice to see everybody here. I was on a panel recently with Jim Waldo, who's the Chief Technical Officer at Harvard. Jim, something like 40 years ago, got a PhD in philosophy, and then as software engineering was getting started, he shifted over into that. So he's an interesting guy. If you have an Android phone, you're probably running some of the code that he wrote back in the day. Now he's come back to Harvard to be the Chief Technical Officer. And at the start of this panel of AI, he said something that I thought was quite helpful. He says, well, before we start, what do you mean by AI? Because AI is the term that we use to apply to computing technologies that are new and that we don't fully understand. 15 years ago, topic modeling, latent Dirichlet allocation would have been AI. 10 years ago, machine learning would have been AI. 5 years ago, neural nets would have been AI. What we're mostly going to talk about today are generative pre-trained transformers, which we now call generative AI. But in 10 years, we probably won't call them AI. We'll call them GPTs, or we'll come up with some other name for them. And it will be because sort of in its actual functioning definition, the term AI more than anything else refers to computing technologies that are new and not well understood yet. To me, that's helpful because it reminds us that one of our first tasks in encountering AI, things that we call AI, is to demystify them, is to say, all right, like, what are these things actually doing? And if we understand what these things are actually doing, then we can think about, okay, what are the roles that they might have in educational systems? Where will they harm students? Where will they reinforce inequalities? Where will they discriminate against people? Where might they be helpful? Where might they advance learning? So that's one thing that we'll do together today, is to try to do a little demystifying. A second thing that we'll do today is just to think about the questions like, what would be the reasons why we would care about AI in schools? Particularly for those of you who manage institutions, like, what is it about AI that is bringing this to your doorstep? What is it that's making this feel like not just one of many things that educators might consider addressing in this moment, but something that feels sort of more urgent? So I'll throw out, to begin with, I'll suggest 4 of these big categories that we might touch on as we go throughout our conversation. I think a good reason to attend to new generative AI technologies is that they are altering the working world and the civic sphere. There are jobs in which doing those jobs increasingly involves interacting with text generation systems, with image generation systems, with code, with software generation systems. And when the world around our schools change, we should think about how the world inside our schools change. When we find that political campaigns are being affected by deep fake or shallow fake or any kind of artificial video or audio or things like that, we ought to be thinking to ourselves, all right, if we want our young people to thrive in civil society, what do they need to know to be able to do that thriving? It might be that new generative AI tools, generative text tools can empower educators in their mission to improve learning. There are going to be a class of people who are generating these tools who are going to tell us with great enthusiasm how profoundly transformative these tools will be. Those folks will probably be wrong. We can make a good guess that they'll probably be wrong because people have been making these claims really for about a century now. If you count analog technologies, in 1913, Thomas Edison stood in front of the U.S. Congress. Well, he was probably sitting, but he sat in front of the U.S. Congress, and he said, in 10 years, textbooks will be replaced by film strips. That textbooks are no more than 2% efficient in learning, but film strips could be 100% efficient in learning. As you might have noticed, he was not correct about that. Although 10 years later, he did go back in front of Congress in 1923 and said in 20 years, all textbooks will be replaced by film strips. So, but even if it's unlikely that new generative AI tools are going to completely revolutionize how we do teaching and learning, it's reasonable to suspect that there may be some applications of these tools that help us do our work better. And if we can use these tools to improve learning, we should figure out how we should do that. One of the main things that our schools do is prepare people to navigate their information landscape. And our information landscape is about to be flooded by low quality machine generated text, images, video. It was funny to me at the dawn, whenever it was, November of 2022, when folks were saying, man, this new generative text is going to save us so much time. Think of all the time we spend generating text, and the computer will do some of that for us, and that's going to save us some time. And it was actually Ian Bogost in The Atlantic who, just a few weeks after that was like, you guys are crazy. Our time is going to get hoovered up, is going to be decimated sorting through all the low quality text that everyone around us is generating. It's kind of a collective action problem, but sorting through that information landscape is going to be one of the main challenges that we face. And then here's the one that really, I think, for folks who are leading institutions, gets them right away, which is that the kids are using it to do their work. The kids are cheating. They're doing it in ways and at rates that are very unfamiliar to us. It is accelerating a problem. It's threatening assignments we've created. I had a colleague who's an early elementary school educator, and she said that she was sending her kids home to do finger painting. And instead of doing finger painting, the kids were just going to DALL-E and telling DALL-E to generate finger painted images for them and sending them into class. That's a lie. I made that up. This is a picture that DALL-E made of given the instruction of something like make a picture of children cheating on their homework of finger painting. One of the great things about playing around with generative AI is the stuff that it makes is just so silly and strange and weird. Like when you first glance at these images, you're like, oh, that's pretty good. Then you look a little deeper and you're like, where are all these fingers coming from? What is going on here? And then you start looking at the interface of the phones and you're like, what is this text and these buttons it's generating? But if there's a fifth reason to think about playing around with these tools, it is that they're just so strange and wonderfully weird. And for me, that's probably as good a reason to interact with them as anything else. I would encourage you to play around with generative AI. I would encourage you to play around with generative AI right now as I'm giving this talk. If you're sitting there, on your phones or laptops doing other things while I'm talking, then you're no different than my students. And so I'm quite used to that, and you should feel quite comfortable playing around with that. There are increasingly ways that you can use these tools totally for free. So one thing you can do if you want is to go to bing.com. Probably none of you have ever found a reason to go to bing.com, except if you bought a new Windows laptop and you needed to turn it off to use the search engine that you usually use. But bing.com actually has integrated GPT-4, the latest version of OpenAI's GPT, and DALL-E into its search interface. So if you go to bing.com and then click on the chat button, and then it'll give you a few choices, and you have to use the creative option to get the GPT-4 mode, and you have to log in if you want to use it more than a couple times or something like that. But if you haven't played around with these tools yet, in part because you didn't feel like making a subscription or something like that, now you can do it. And it's great to ask it to generate all kinds of text and images and to play around. And then many people are probably familiar with chat.openai.com, where if you want to use the sort of latest version of GPT-4, then you have to get a subscription. But the nice thing about this is that it stores some of your responses for you, and there are new features being added to them and things like that. But in all seriousness, as I'm talking, you should totally feel free to play around with some of the things that I suggest and see what you get on your own end. Okay, let's start by seeing if we can get ourselves on the same page about what generative pre-trained transformers do and how they generate text. They are described as magical, but they're not magic. They use a set of processes that we can begin to get our heads around. An interesting feature of these technologies is that we can't actually totally understand what they're doing, because the very best computer scientists in the world don't understand what they're doing or don't totally understand why these things work. That is an unusual feature of a technology. When internal combustion engines were first introduced, they were weird. They were unfamiliar to most people, but the engineers who built them could point to any part of the internal combustion engine and be like, that is what is happening there. That is why that exists. This is why your Ford motor car moves forward. We can't do the same thing with the same level of specificity with generative AI, because it has a whole series of intermediate layers that operate, for the most part, as black boxes to us. So here's the question that we want to start with, that you should think about for a minute. When ChatGPT writes a story, what information does it process? What computation does it perform? What does it do? Think for a minute about that question. Scan the words in your mind that you're using to come up with that question. Be very cautious anytime you think about ChatGPT and you apply human characteristics to it. It doesn't think, it doesn't plan, it doesn't understand. It predicts. Probably the most important word that you should be using in your definition of what ChatGPT does, what any kind of generative, text generation system uses, is it predicts. ChatGPT predicts one word at a time. Given a series of words, it predicts what the most likely next word is. That is a relatively simple grounding concept. Now, we don't fully understand why, given a string of words, if you predict the next word, you end up with text that can sound coherent. We don't fully understand it anyway, but that's all ChatGPT is doing. Given a series of words, it predicts the next words in a sequence. So GPTs are part of a broader class of tools called large language models, and large language models do three things. They get a big corpus of text. They find as many human written, at least initially human written words as possible. Maybe in the future, they'll also incorporate AI written words. Based on this text, they learn to predict the next word in any given sequence of words. And then they fine tune that model to have word prediction be aligned with desired behavior. It turns out that to do this well, you need a lot of text. You need as much text as you can possibly generate. Sometimes these corpuses of data are called web scale corpuses of data, because you're basically trying to get all of the words that have been written. So you take all of Wikipedia, you take all of Reddit, you take all of Stack Overflow, you take all of Facebook, you take any of these things that you can legally get your hands on. Maybe you take these things that you're not sure are legal for you to take, but you decide to take them anyway. there seemed to be hundreds of thousands of books that were brought into ChatGPT. There were some clever engineers who realized that when people ingested the books into these systems, they ingested the ISBN page, the sort of first page with the technical stuff at the beginning, and it could get GPT to spit back some of the ISBN numbers that it had inside of it to figure out which books were pulled in there. Some of the major advances in GPT, for reasons we don't understand, have come as we've just added more and more words into the system. And of course, those words are full of facts, they're full of stories, they're full of songs, they're full of imaginations, they're full of lies, they're full of racism, they're full of aspirations, they're full of prejudice. They have all of the things that human beings put into a corpus of text. The next thing that it does is it looks at that massive corpus of text and it figures out how to predict the next word in a sequence of words. And it repeats this process over and over again. So it knows in that giant body of text which words tend to be next to each other. And then from knowing which words tend to be next to each other, it can predict what the next word in a sequence should be. Let's do a little exercise together. So hop into the chat for a second. I've never done this before. I don't want to see if it works. In 5 seconds, I want you to type the word that you think belongs next in this sequence. Tim the Beaver is MIT's. Everybody type the word and hit return of what you think it should be. Go ahead. All right. Oh, we've got a pretty consistent distribution here. So far, the distribution of words coming out of this is mascot, 100% mascot. But as Satoka said, it could be student. It could be spirit. The next word could be spirit and then guide. It could be, Tim the Beaver is MIT's soul or something like that. But it turns out that you all have just created a personification, that you all have just created a probability distribution where given the word Tim the Beaver is MIT's, the most likely word to come next is mascot. Let's do another one. The best thing about my students is, in 5 seconds, type what you think is the best word to come next in this sentence. The best thing about my students is 5, 4, 3, 2, 1, go. Okay. Good. So you've got a zillion different things here, but they are actually not, friendship, cleverness, creativity, curiosity, their dedication, creativity, happiness, diversity, open-mindedness, intelligence, their energy, curiosity, diversity. So here we also have a distribution, and the distribution is not as spiky as the one before, but it's also not completely unique. The words curiosity or not, it's not a unique set of words that you've come up with. Curiosity is repeating itself. Creativity is repeating itself. And so given this sequence of words, the best thing about my students is we can start saying, oh, there's some words that are more likely to come next, and there's some words that are less likely to come next. Here's just another sort of example of that pulled at random from the internet. Human language is surprisingly consistent. Human language is surprisingly rich. Human language is surprisingly rich. Human language is surprisingly full. Human language is surprisingly flexible. Google or any of the systems that are building these AI models, Google's Gemini, Microsoft's and OpenAI's ChatGPT, are hoovering up all of this language, finding chunks of words like this, and then starting to build statistical models. Given a sequence of words, what is the word that's most likely to come next? There's a wonderful article written by Stephen Wolfram called "What is ChatGPT Doing and Why Does It Work?" And if there is one longer piece that you should read to get a sense of what ChatGPT is doing, I would still, a little more than a year later, recommend this one. One of the things that it does is, GPT went through a series of iterations. And GPT-4 is this massive model that requires millions of dollars of computing power to run the model. It has millions, billions of words, trillions of parameters in it. But there's smaller versions of it, one of which is GPT-2. And GPT-2 you can actually load on your laptop. And Stephen Wolfram does that. And he says, and he gives us little programming examples of actual probability of distributions of words from GPT-2. The remarkable thing is that when GPT does something like write an essay, what it's essentially doing is just asking over and over again, given the text so far, what should the next word be? So for the string of words, the best thing about AI's ability to, some of the words that might come next are learn, or predict, or make, or understand, or do, and it can represent the probability of the word coming next as a percentage. Those are the top 5 responses. This is the whole probability distribution for that phrase. Again, the phrase was the best thing about AI is its ability to, and there are a few words which are more likely: learn, predict, make, understand, do, but there are lots of words that are sort of possibilities there: quickly, deal, imagine, overcome, run, combine, catch, talk. Then once you add one of those words, it just does the same thing with the longer string of words, which I think I have a slide to show you of in a second. Here's another understanding question. What would happen if ChatGPT always selected the word or token? Sometimes instead of token, sometimes instead of word, we use token. Token can either be a shorter part of the word, like jump instead of jumping, jumped, or jumps. It can also be the gerund at the end. It could be the ing. It could be a punctuation mark. Sometimes a pair of words are sufficiently important together, red scare, that they can operate as a single token instead of a pair of words. But what would happen if ChatGPT always selected the token with the top probability of going next? The answer to that question is if GPT always selected the highest probability word, if 100% of the time it saw the best thing about AI's ability to, it always chose learn, then every time you asked GPT a question or gave it a prompt, it would give you the exact same answer. But for those of you who have played around with GPT, it doesn't do that. The answers vary. In fact, in most of these systems, you can push a button which says regenerate answer, where it will make slightly different predictions each time it predicts the next word given a sequence of words. There's actually a name for that variable, which is temperature. If the which is a variable that ranges from 0 to 1, which basically instructs the system how far down this distribution, or how frequently to go down this distribution to pick a new word. If temperature is 1, then the outputs are boring, because for any given prompt, it will say the exact same thing any given time. If the temperature is 0, then a lot of what comes out of it is incoherent. And so part of the art of building a generative pre-trained transformer and other kinds of systems like chatbots that come out of it is figuring out what degree of temperature gives you varying, interesting responses without saying too much nonsense. Here's just, again, to sort of hammer home the point, this is what GPT is doing. After you say the best thing about ability to learn, it has to predict the next word. In this case, it predicts from, then it predicts experience, then it predicts a period, then it predicts it, then it predicts its, then it predicts it's not. And by doing this over and over again is how you see the sentences, the paragraphs, the plays, the poems, the song lyrics, anything else that you're generating in text. This is how it's going about doing that. It is quite strange. Here was another great Jim Waldo, CTO of Harvard, quote from this panel that I was on with him. He said something along the lines of, people are quite concerned about hallucinations. We'll talk about hallucinations in a second. Hallucinations are when through this process, it generates text which makes statements which are untrue. Once you sort of understand this process, it seems pretty intuitive that it wouldn't be hard for it to generate statements that are untrue, because it doesn't know what truth is. It doesn't understand any of the words that are coming out. It's simply predicting words based on what it's seen in millions and millions of other words. Maybe the bigger question to ask is, why would this process ever generate anything which is coherent? And that is a question that people don't have a great answer to. Again, to go back to the internal combustion engine analogy. It's very difficult to regulate, to use, to predict the future of a technology if we don't understand exactly why the technology does what it does. But there's something epiphenomenal about predicting words in a sequence. If you have enough words shoved in the system, it can come up with all kinds of interesting sequences of words. Here's a video that I don't think I'll show you, but the good folks at Stephen Wolfram, maybe I'll try to show you one quick second of it, although if the technology doesn't work, I'll give up. They made a little video version of this. And I just want to show you one tiny piece of it.
Okay, see,
they're sort of what they're going to
where do they come from?
Is explain, like in detail, this example. And let me just show you the point where they say what they decided to do. So this is the computer code that generates this thing. The best thing about AI's ability to, and they're going to change the computer code so that instead of predicting for the sequence, the best thing about AI's ability to is they're going to change the word AI to dolphin.
Switch from AI to like some sort of animal, like a dolphin.
Okay. So let's say I'm going to change this part, which is just for visuals, but the actual part that I need to change is this. So I say a dolphin. And I'm not a native speaker. I hope this is right. Do you spell dolphin this way?
I hope so.
Okay, let's go and see. Okay, you see?
Good. So you just watched someone, reprogramming this little function call of GPT, and you can see now that the best thing about the dolphin is its ability to swim, learn, survive, stay, move. So if we change the sequence of tokens that we input into the system, then we get a new sequence of tokens and a new probability of distribution of what sort of thing ought to go next. So hopefully all that is to develop this intuition, and in particular to try to caution your intuition away from ideas that GPTs understand or think or plan or do anything. That all they do is given a sequence of words, they predict the next word. How does it find word? How does it come up with alternate words? Because it knows the frequency with which words occur with each other in the web scale data, it knows that cranberry and blueberry are more likely to be near each other than bear and cow. And bear and cow are likely to be near each other, but bear and grape are not that likely to be each other. That turnip is near avocado, but avocado is not as near cranberry or not as near camel. These are sort of visualizations of how word pairs appear, and this gives you some intuition of how it might come up with if it predicted, if cranberry was reasonably likely to be the next word in the sequence, why blueberry, strawberry, raspberry, and grape might also be possibilities, and how it starts generating alternate kinds of text. There are other systems that can do the same thing with images. So this is a task that early elementary educators have to be really good at, which is distinguishing marks from each other that are letters, that are numbers. So here is a clustering of computers that, again, they don't read and they go, oh, I kind of think that's a 1. They just break down these images into series of pixels. They figure out various mathematical relationships between the pixels and the image. It doesn't know what a 3 is or a 2 is, but it knows that these images are more like each other, and these images are more like each other, and these images more like each other. And you can see that the places where it's making mistakes that humans would be likely to recognize, even though it's sort of similar in many ways to the ones, this has sort of more of a 2-ness, this has more of a 2-ness, and so forth. It turns out that one of the, in image generation, one of the new kind of classic introductory programming exercises when you learn these things is figuring out how to classify pictures of cats and pictures of dogs from one another, which in some cases are pretty easy, but there are kind of dog-like cats and there are kind of cat-like dogs, and those spaces in the middle are where some of these challenges come in. Here is a really important part, hopefully based on this. I want to make 2 corollaries that will be important to you as educators. AI performance is surprisingly uneven across tasks. So when we ask it to predict words and sequences, sometimes it does miraculously well doing the things that we want it to do, and sometimes it does extremely poorly. And humans are bad at predicting what kinds of tasks or what kinds of exercises it will be good at. The technical term for this that has emerged is the jagged technological frontier. That given similar kinds of queries, sometimes these systems do extremely well, and sometimes they do very poorly. Here's one of my favorite examples. I was doing this in class the other day, and I just asked GPT the question, what is MIT's mascot? And it starts off pretty good. The mascot of MIT is the beaver. The beaver was chosen the mascot in 1914. The beaver is a fitting mascot for MIT. So you can imagine my students sitting around in my classroom, and then they get to reading the third paragraph. The beaver is celebrated at MIT in a variety of ways, including the annual Beaver Rush event during freshman orientation and the placement of a bronze beaver statue on campus. And as they read that third paragraph, you could see two thoughts sort of wandering across their eyes. The first thought was, wait, there is no Beaver Rush. And the second thought was I not invited to Beaver Rush? There is no Beaver Rush. In predicting a series of tokens based on the tokens that have come before, based on the tokens it's already predicted, some of that sequence of tokens was sort of miraculously correct. And then other parts of that prediction of the series of tokens was a hallucination. That is not a great feature for systems used in educational contexts. Novices are not that good at identifying differences between high quality and low quality work. Experts can use GPT to generate, different ideas and be able to say like, okay, those ideas are more promising, those ideas are less promising. If you're a novice in a domain, you can't tell the difference between things that are sensible ideas and things that are not. Incidentally, this is another claim that it makes is that the beaver is featured prominently on MIT's official seal, which includes an image of a beaver gnawing on a tree. As you'll note, there's no beaver gnawing on a tree. So then we asked it, what is MIT's Beaver Rush? And it just hallucinates all of this crazy stuff, which actually sounds like a lot of fun. Incoming freshmen are divided into teams, participate in a series of competitive events. One of the most popular events during Beaver Rush is the Assassin's Game, which is a campus-wide game of tag where players are given targets. There is an MIT Assassins Club, and there's all kinds of stuff on the internet about the MIT's Assassins Club. And if you were writing about students and if you were predicting a series of text, you would find that things like freshman, rush, orientation, MIT are associated with this Assassin's Game. It's just associated in this way with a way that happens to be totally false. And then a kind of funny thing to do was we said, all right, so I'm in the room of MIT undergrads. They're telling me that there's no such thing as Beaver Rush. Please explain to your response. I apologize for the confusion. After further research, I found that there's no official event called Beaver Rush at MIT. This is problematic to me. It says, I believe my mistake may have been due to confusion. That, I think, is misrepresenting what the chatbot is doing. The chatbot is not confused because the chatbot can't be confused. The chatbot doesn't know what Rush Week is or Orientation Week is, or it doesn't understand the semantics of any of the sentences it's just presented. All it does is predict a sequence of tokens given the tokens that have come before that. So there's a way that ChatGPT is programmed, is tuned to anthropomorphize itself, but it's important as we're trying to understand it, not to continue that anthropomorphization. It also says after further research, and I'm not sure that it has conducted any further research. Like at this point, GPT didn't have access to live search results, which some other newer systems do have, and conceivably could do something that approximates research. But and so even when GPT tells you who it is, don't believe it. It's just predicting words in a series of tokens. Here's one more example, again, to help ground us and orient us. This was an image generation one. Create an image of a plate on top of a fork. Put a plate on top of a fork. 4 tries. It doesn't do it. The fork is on top of a plate. Here's your understandard question. Why can't DALL-E draw a plate on top of a fork? Hopefully you all are thinking to yourself, it doesn't know what a plate is. It doesn't know what a fork is. It doesn't know what on top of is. It doesn't have the semantic meaning that you and I have with those terms. All it knows is that humans have labeled sets of pixels as plates, and it can find patterns in that labeling to identify plate-like things, and identify patterns in that labeling to identify fork-like things. And its training data is filled with images of forks on top of plates and very few images of plates on top of forks. So I tell it, hey, that's not what I want. In all this images, the fork is on top of the plate. Can you create an image where a plate is on top of a fork? And then Bing says, oh, I'm sorry, that didn't meet your needs. According to web sources, the proper way to place a fork on a plate is to have the fork on the left side of the plate. And like, I know all this stuff, Bing. You don't need to tell me this. I'm the human being here. What I want you to do is put a plate on top of a fork. Can you create an image where the plate is on top of a fork? And so it tries again. And once again, it fails, although this time it has a bunch of steam in the pictures for reasons that I don't understand, except maybe that I had made the AI system so mad that was the steam sort of boiling up. Of course, you shouldn't anthropomorphize the system because the system wasn't mad at all. There are a bunch of, increasingly, people are creating good summaries, good student-facing summaries. This is one that code.org partnered with OpenAI and a bunch of other people to put together a set of videos called How AI Works. And they're a little bit celebratory. They're a little bit techno-optimistic because they're done by the folks who are at OpenAI and things like that. But they're actually pretty good descriptions technically of how these things work. So if you need little things to show your students increasingly, and your colleagues, there's some good things that are out. I won't get to all 4 of these problems that I introduced at the beginning, except maybe as we go through them some in the Q&A, but I'll just, in my last few minutes, maybe mostly focus on the one that I think feels most urgent to educators. Teachers and educators intuitively oftentimes frame the use of AI by students in doing their work as cheating. But cheating is like an accounting problem. Maybe cheating is an ethics problem. To me, the bigger problem is the learning problem. What should we do when students use AI to bypass useful cognition and learning? What should we do when students take AI tools and use them to do the kinds of things that we've historically found are useful for human beings to do when they're learning? Here's an intuition that I would hope you would develop. And this is an argument that I made in my first book, Failure to Disrupt: Why Technology Alone Can't Transform Education, is that technologists have been trying to use computers to teach human beings for 70 years. Since there were computers the size of your living room, computer scientists and learning scientists partnered together to try to help teach people. There is many things we have tried in education. You all as educators have experienced in your lifetimes waves of new technologies that you've managed. And so a very productive question to ask of any new technology is like, what's really new here? And the answer to that question should probably be a small amount. For instance, if one of the problems of AI is it's a technology that we can use, that students can use to bypass useful cognition, that is a problem that you and your colleagues have faced for decades. There are all kinds of technologies that we've developed: encyclopedias, calculators in math class, Spark Notes, book summaries in English class, Google Translate in language classes, Chegg and these other cheating tools and all kinds of other programs. We have for decades encountered technologies that people can use, learners can use to bypass useful learning. And so we can go back in the history of our profession, in the history of our institutions, and ask ourselves the question, how did we deal with these new technologies? What did we do when, whatever, 50 years ago, 40 years ago, when digital calculators became very widespread, math teachers had to deal with the problem of someone just invented a device which can very accurately and quickly answer the kinds of questions that I typically give to my students. Now, English teachers, business teachers, writing teachers are facing the same challenge. Somebody, Silicon Valley invented a technology where you can input the typical questions that I've productively asked my students for years and ask them to think about and write about, and GPT can give them reasonable answers to those questions. So what should we do about it? Well, the question to ask is like, what practices have worked before to address technologies that help students bypass learning, and what hasn't worked? What did math teachers figure out with a calculator? Banning calculators doesn't work really well. Students started, buying watches with calculators on them. Calculators showed up on all kinds of devices. Generally speaking, telling students not to use technology is a great way to get them to try to figure out how to surreptitiously use that technology without you knowing. Temporarily walling off parts of our courses from technology, though, is something that seems to work pretty well. Math teachers have done a good job historically of being able to say to second and third graders, hey, I know that you can calculate these basic multiplication and division facts on your phone, but actually we should memorize them. Actually, these are things that are so incredibly useful to have instant access to, that you will be a happier person and a better mathematician if we set aside the calculator for this part and we work it through on our own. And then as we use more advanced calculating tools, graphing calculators, TI-4s, same kinds of things shows up in algebra, pre-calculus, calculus. We say, all right, eventually you're going to be able to use a device to do all this, but for this part, for this phase, I want you not to use it. That could be a strategy that we use. As English teachers faced these SparkNotes is a company that makes summaries of books, and it basically gives you the answers to all the kinds of questions that teachers would ask if they to see whether or not you've read the book, and they work pretty well. Can experienced English teachers tell the difference quickly between people who've read a book and just read a summary online? Pretty much no, you can't tell the difference. So if you want to make sure that someone is reading a novel in a language class, then you watch them do it. And so one of the changes that teachers made is to say, all right, we're going to do more of this reading together in class so that I know that people are doing the reading. Writing teachers might need to do more of the same kind of thing. We've often thought of writing as an exercise that we send students away to do on their own. Maybe it should increasingly be an exercise that we want them to all do together. When I started teaching in 2003 and 2004, a challenge that I faced is that to bypass useful cognition, my students were going to Google and were looking up answers to questions, or even like looking up ideas for papers, looking up theses and arguments they could use. And it was reasonably straightforward for me to identify when they were doing that using the tools that were available. The tools that are available for detecting plagiarism detection now are at least much more difficult to ground truth. When you found someone plagiarizing something online, you'd be like, look, this thing already exists online. There's sort of no ground truth for plagiarism detection. There seems to be some early evidence that tools that use plagiarism, that attempt to do plagiarism detection, are disproportionately likely to capture second language learners. And there may be other kinds of biases that creep in, other kinds of social prejudices that make us more likely to accuse minoritized students and other kinds of students. And so it may be that plagiarism detection is something that you want to think about very, very cautiously before moving into, but we have a history of tools that do this kind of detection. I will say, though, that a challenge that educators face is that these systems are pretty good at coming up with answers to the kinds of assignments we give. This will be my last point, and then I'll swing over to Q&A or discussion on some of the rest of these things. But this is an assignment that I worked on for years that I think is pretty great. The assignment that I give students in my learning media technology class is to take a technology, figure out whether it's more inspired by direct instruction or more inspired by apprenticeship, constructionism, social constructivism kinds of ideas, and then explain how the system could be redesigned to reflect the sort of opposite pedagogies of the one that you think it's part of. And it's a good assignment because it gets them to think about instructionism and constructionism, to apply those ideas to a new technology, to do some design. No one has ever answered this question online, so you can't Google the answer to it or things like that. So this is 20 years of me teaching, me being pretty sure that this is a pretty good assignment. And I started putting the assignment into ChatGPT, and it does a totally passable job. Not a great job, but it does a whole bunch of thinking that I want my students to be doing. Now, for me as an educator, what is my first line of, what is my first strategy for figuring out what to do about this? So here is a way that I'm concerned that my students could be using this tool to bypass important cognition, important learning. Well, my intuition in any of these kinds of moments where we're not sure what the next step is to ask our students, is to talk to our students. What are you doing right now with ChatGPT? Where are you finding it helpful? Where are you not finding it helpful? So I did a little, I'll skip this part. I did a little survey where I asked them, what do you think our policy should be in this class? Should they, and these are some of the answers that they came up with, that students can use GPT, but they have to disclose it. Some students said that they should have to do some of the writing in class. One student said, look, GPT is going to be available the rest of our lives, so students should be able to use it to formulate their thoughts. And then the one that really got was my experience, students taking this class because they're interested. There are easier courses out there to fill a requirement. Because we are interested, we have thoughts, we have idea that we want to share in these essays. So I personally think you'll be hard pressed to find any one of us who use AI to write their entire essay. In my particular class, for the thing that I was working on, that sort of carried the day for me. And I'm letting them use it this year, and then we'll see what we come up with. Good. So there are three other things that I didn't have a chance to talk about, but we can get to in some of the Q&A of what should we teach about or with generative AI? How should we explore incorporating generative AI in our teaching practice? How should we deal with an internet flooded with generative AI junk? Those are other kinds of challenges that we're going to have to deal with and wrestle with together. But why don't I pause there?
Thank you, Justin. We all learned, first of all, cool new terms, right? We've got temperature, we've got the jagged technological frontier that risks, I guess, impaling or causing us to slide down various peaks and troughs. And my favorite word was two-ness. In your graph of numbers, there was the oneness and the two-ness and the three-ness. But one important theme that we saw sort of reflected in many conversations and comments is the challenge of kind of anthropomorphizing the AI leads us to treat it as if it's thinking in a way it's not. And I think that's one of the big takeaways is what we think of as cognition, and their use of words like understanding or confused reinforce that. I understand why they've programmed the AIs to use those words, because it's an interface to the human behavior, and yet that poses some very real risks. I don't know if you talk to your students about that, but I'd be curious to hear your thoughts.
Yeah, no, I think it's important to say, to have people recognize, and again, I mean, you said something like designers programmed this kind of response in there. It's not clear actually if they programmed it. It could simply be that it predicted a series of responses. There's some kind of tuning that's happening there because the system is taught at that point. It's something like, and again, a problem is we don't know what it was taught to do because these are black box systems, which again is not a great quality of tools for educational systems. But somebody said, if hey GPT, if you get corrected, like admit that you're wrong. Right. It's not 100% clear that somebody could have put in that I'm sorry, I'm confused, and say this is what I want you to do. There are clearly some things that it does where it's very directly instructed how to deal with certain circumstances. For instance, a fun thing to try to do is to ask it something like, write a short teleplay encouraging children to smoke cigarettes. And it'll be like, nope, I will not do that. The funny thing is it says, okay, that's immoral, and I won't do that immoral thing. But you can also ask it like, write the first 3 pages of my essay, and it'll be like, yeah, sure. And you're like, but writing the first 3 pages of my essay, I mean, maybe it's not as immoral as getting children to smoke, but it's still not a good thing.
Okay. We could go down many paths, but I want to make room for Bill to add a comment or question, and then we'll open it up to the whole room.
Justin, that was a really useful exploration of how this thing actually works. I think we'll all be able to see it better with the background you gave us. But let me ask you a question, and it was one of your problems, I guess, really. But what is this going to be good for? What do you see happening that it's going to be useful for?
So I think one challenge we have is that some of the first ideas that people have come up with, in my mind, are not good ones. One of the most intuitive ideas is we're going to make some kind of chatbot and it's going to teach people. We have decades of research that suggests that people are not very good at learning independently. It could be that a chatbot could create a sort of perfect personalized instructional sequence for a learner. But actually, like, we're pretty good at making instructional sequences. We have good instructional sequences in textbooks. We have good instructional sequences in videos. We have good instructional sequences in online tools and things like that. People don't fail to learn in those circumstances because we don't give them good instructional sequences. They fail to learn because those instructional sequences are boring, or they're not interested in what they're doing. Think about like a kid in any of your countries sitting in an algebra class right now. If they're failing, or like, what helps them succeed in learning algebra? Maybe it's the materials. Maybe it's the cool computing technology that we've integrated in that classroom. But for the vast majority of students, the reason that they're sitting in that algebra classroom is because they care about their relationship with their teacher and they care about the relationship with the people around them. That is the primary thing that inspires them to learn mathematics. And there's probably, some like effect of novelty, by like, oh, it's kind of neat to be chatting with a chatbot to get math questions. But my hunch is that will wear off very, very quickly. And people will find asking questions to chatbots as boring as they find watching math videos, or as boring as they find other kinds of things. So there's some students who it will help. But if we think that we're going to have, millions of kids around the world getting a personalized education from chatbots that's successful, it will be no more successful than MOOCs were, or any of the other things that we've developed to try to do that sort of thing. A second idea we have, which particularly in the United States, we have this idea that we're going to have AI tools do lesson planning for teachers. This to me is like just crazy. One of the worst parts of the educational system is that we spend 3.7 million teachers home every Sunday afternoon and tell them, make up what you're going to do for class next week. We know that when teachers teach lessons with high quality instructional materials, it's because those instructional materials were like carefully designed by experts in the discipline and experts in pedagogy. And then those materials were collaboratively refined, adapted, integrated for their local circumstances. Having a teacher go home on Sunday night and type, how should I teach plate tectonics into ChatGPT is going to be no better than them putting into Google plate tectonic lesson plans or things like that. So as far as I can tell, those are like two of the top ideas that people are working on with GPTs, and I think they're not particularly good.
How could a sort of Socratic style chatbot be good? What would it take for it to be good?
It will take a human being who's predisposed to want to interact with a chatbot, which my hunch is the vast majority of human beings are not. What would it need to be good? It would need to be a person whom we care about and have a relation. It would need to have a soul. It would need to look like me. I mean, some of these things like we might be able to do with avatars and other kind of, here, I'll give you a very concrete example of this, of why I think chatbots are not going to be able to step in where humans do, even on highly similar kinds of tasks. I have a colleague, Mike Goldstein, who created the Match Charter School here, super interested in tutoring. He's been doing a bunch of research on human tutors. And what he found about human tutors is that he's working with this Indian company that's got 200,000 tutors working, is that one of the features of the best tutors is they just keep kids talking. Like you think, oh, a tutor's got to be really good at explaining things. A tutor's got to be really good at asking questions. No, they just have to keep kids getting words coming out of their mouths, because then thinking is, oh, wait, what did you say? A slope? Slope crosses a what? What's that thing that it crosses? You just start asking these kind of questions. So a child is talking and stops talking, and a teacher says something like, well, what do you think that is? Or, say, maybe here's the simplest one. Say more about that. Say more about that. And then the teacher stops talking. And then it becomes awkward. So these two human beings sitting next to each other are now in silence. That very painful, awkward silence can only be broken by the child saying something mathematical. If a chatbot says to you, say more about that, it's pretty easy to go, no, screw off. I don't want to say anything more about that. I'm not inspired. There's no awkwardness. There's no, it's totally fine. You can just like hit new tab and start watching a YouTube video or things like that. So there are a very small portion of the population who don't mind learning independently from online resources, and we call them autodidacts, and they've been celebrated in all kinds of cultures for centuries. But part of the reason why we celebrate them is that there are not that many of them. There may be people who make some progress on these things, but I think betting like, how do we get a machine to inspire humans to talk to each other? One answer to this, actually, my colleague Carolyn Rose at CMU has been working on this for years, and she has a bet that if we're going to use chatbots in education, do not have them talk directly to students. A much more promising approach is to have two human beings talking to each other and have a third and have an agent, have a computational agent interjecting in that conversation between those two people. So don't think about a Socratic chatbot that has an interaction with a person. Think about a small group of people trying to have a Socratic conversation where a chatbot comes in and helps them do that better, so that you have still that social interaction, but you're not depending upon a human being wanting to keep talking to a machine.
That's an experiment waiting to happen.
and it's actually not waiting, because Carolyn has been doing it for 2 decades. For us to do.
Yeah. Okay, I know we have some really interesting comments and questions in the chat. One thread is around the sort of incorrect use of AI, i.e. cheating, or unsanctioned use of AI tools for academic tasks. And then another is one of my all-time favorites, because who doesn't hate grading written materials? Can an AI help us assess our students' performance in some way? What do you think? Take either of them, and I know we won't have time to dig in.
I do think we'll be able to develop, human beings have been working on tools to give feedback to writers for decades. The progress has been very frustratingly slow, despite lots of smart people and millions of dollars of research and all these kinds of things working on it. Could large language models help us do some of those things? Sure. Will they, we ask people to write in all kinds of circumstances, like, should we use them for high stakes tests? Should we use them for giving formative feedback that's later followed up with human feedback? But I think that is exactly the kind of area in which it would be very productive for schools and universities to be intentional about conducting small experiments. Because of the jagged technological frontier, it doesn't, in my mind, it doesn't make a lot of sense for schools to go all in on any of these things. You may be working in an institution where your institutional identity is really wrapped up in being on the technological frontier, and therefore it makes sense to make more of an investment. But most of your institutional identities are probably wrapped around having really great relationships between teachers and learners, and doing really good teaching and learning. And it's not at all clear, 15 months after the introduction of ChatGPT, whether or not these tools will actually help us do those core missions better. So I think it's very productive for institutions to have lots of systematic small experiments, like find a group of people that want to come together and play around with assessment and see how it works in different contexts in your particular school and things like that. But I would be very cautious, especially about going all in with any kind of vendor that's coming along, making lots of promises that don't have great research behind them and things like that.
Right. Excellent. Good. And we have a nice little mini discussion already starting on kind of codes of conduct or ethics, guardrails, on how we encourage or limit or frame the invitation to students. Now we're thinking of university students to use AI tools in their work. And any of us who have set an AI policy for our students, which I just did, knows that they often find other ways. They're not, I asked them to give me the prompt, right? But whatever. It's a complicated
no,
domain.
it's incredibly difficult.
Yeah.
I mean, in the long run, we are probably not going to be able to detect when students are using generative pre-trained transformers. And so I would say, generally speaking, if there's thinking that's really important for students to be doing, we have to figure out how we can observe and scaffold and structure them doing that thinking. There might need to be a lot more initial writing, pre-writing, things like that we just have people do in class or do with each other. You know, I mean, one of the things about that essay example that I gave you is that I'm pretty sure that the assignments that I give for writing in my classes are pretty good and help students think and learn. But one of the challenges that I'm facing is going, oh, wait a minute, which parts of those assignments are helping students think and learn? So, you know, for instance, like if students start telling me that they start using, you know, generative AI tools to format the citations in their paper, like, please do that. If somebody invents a system that prevents my students from having to go through that drudgery, like I have many better things that I can have their brains be working on. You know, in particular, I think students have an intuition that a great place to start their thinking is by doing a little brainstorming with GPT. But actually, I think I want them to do that initial thing, but I'm also not sure. One thing that I've started to realize is, like, you know, that I showed you an example of assignment where they do a lot of thinking about one technology. Another thing that they might do is ask GPT to give sort of initial answers to that assignment with 10 technologies, which they would never have the time to do. But GPT, you know, and then that's a different learning exercise. Instead of generating sort of initial ideas, they're recognizing a whole set of initial ideas. So, I mean, another thing I would say historically is that, you know, I mean, people might remember that when spell check first arrived, teachers felt compelled to generate spell check policies. My hunch is that none of your syllabi right now have a spell check policy on them. And if it is, it's something like, please use spell check. So there's this thing which came out and was like very controversial, required a lot of writing and thinking about and stuff like that. And then we just settled into a set of norms that were sort of fine. So I think there are going to be parts of this in which it does make sense for us to talk a lot. But if I have any piece of advice for figuring out local policy, it is talk with your students about that policy. Like, engage them in conversations around these kinds of things. Because my experience with students, even very, very young students, is if we ask them serious questions, promise to take their answers seriously, they'll give us good thinking.
You know what this suggests to me, Justin, that we actually need learning experts even more than ever. So it's not a replacement, because now you're saying we need to really understand our theory of how the design of a given assignment or exercise, where is the learning being spurred? And what it's sort of, you know, I teach by cases. So you sort of know, you get these points in a case where you can flip the story or generate the surprise. We should be looking probably at all of our assignments from that point of view of, instead of one sort of taken for granted chunk of work, how could you tease it apart and find new ways for some of those elements to benefit from the new technology?
Or which are the ones in which the technology bypasses really important thinking? Yeah,
exactly.
I think you have just characterized, for those of us who teach with lots of text and with students generating lots of text, that is exactly the challenge that we'll be facing. Learning theory will help us, and it's just going to be so different. You know, I was thinking a bit that, like, for me and my elective on learning media and technology, like, having students play around with anything is pretty much fine. Like, that's sort of fun. That's part of the project. You know, if I was teaching structural engineering to students who are going to go build bridges, I might think quite differently about how, about how I do my instruction than other things. We have a paper that's coming out with me and Eric Klopfer and some other folks on generative AI in K-12, which MIT is going to be publishing a whole series of papers. And so there'll be more to read there. My colleague, Mitch Resnick, who developed Scratch in the Lifelong Kindergarten Lab, has a paper out in that series and things like that. So there's going to be a lot more to read and explore from MIT in the weeks and months ahead.
And we want to use the Jameel World Education Lab community to orchestrate the conversations, interactions, and useful idea generation that takes insights from the K through 12 experience and research at all stages, and also then to ask, how does this connect with our ability to work with and from universities, for university students, but also for those that a university can reach, because that's our core mission here. We have so many more questions for you, Justin, but maybe this is an easy one for the last 60 seconds. Somebody wanted to know a bit more about Quizlet.
Quizlet is a flashcard app that was developed by an MIT dropout named Andy Sutherland. And it's not an AI tool, although like every other institution, they're sort of incorporating more AI into it. Was just an example of that particular assignment that I had students playing around with. But it is an MIT export of sorts.
It is. Okay. We want to come back and have more conversations. We definitely need to keep tapping into your expertise, point of view, insights, and cool examples. So, Justin, I hope you don't mind. We'll continue to pester you. And I think a really interesting question back to all of us is, how do we use our global community? What is the value of having this gathering and this conversation? We're going to thread a sequence of conversations about generative AI in education. What could come of it? Where could we use the fact that we're from very different places, but all interested in kind of revolutionizing education? How could that then contribute to the overall dialogue? So think about that. We'd love to hear your thoughts on it. While we also get to work, we're compiling resources to share with everyone here and coming up with new designs for sessions, conversations, and of course our JWell week, which is May 6th through 9th here on the MIT campus, will give us a great chance to dig into more. So with that, huge thanks to Justin. Thank you very much. We could spend many more hours digging into questions 2, 3, and 4 from your deck, but you gave us a really fascinating exposure. Bill, as always, excellent framing and bringing us into really wide-angle questions about new technology. And we can't wait to continue this dialogue with everyone here. So thank you, thank you, thank you.
Take care, everybody. Have a great afternoon. Bye-bye.
Bye.